Hello, welcome to the video. Here's the situation we're looking at. We have a population that's normally distributed. Normally distributed with our mean of 183.3 and a population standard deviation of 50, and we're going to draw a random sample of size 237. Now there's two parts to this question, A and B. Oh, we don't want that there. Two parts to this, A and B. So let's look first at A. We want to find P sub 35. The way to read this would be the 35th percentile of the distribution. It's the scores separating the bottom 35% of scores from the top 65% of scores when we take a single observation from this distribution. So notice we're talking about single values here. So to answer part A, we don't need this information about the sample size. We're just thinking about sampling a single observation. So let's draw a picture here. Let's draw out that normal curve. Nice symmetric bell-shaped curve. Let's put our information about the curve. It's normal with mean 183.3 and standard deviation 50. And we're talking about the 35th percentile, so the bottom 35% of scores separated from the top 65% of scores. So we can sketch a line in here. We don't know exactly where it is, so we're going to put a question mark. We don't know what that is. We do know what our mean is, 183.3. And this value that we don't know, we do know the area on both sides. So we know the area to the left of this, that's 35% of the area, so this would be as a decimal 0.35. Just for completion, we can say, okay, and we know the area above it, color that in green, all the area above that question mark is 0.65, and we want to know what value is this. So the way we can find that, whenever we have a normal distribution and we know the areas but not the values of interest on the horizontal axis, we can calculate those values, those percentiles, using the inverse norm command. Keep in mind when you use the inverse norm command, it always wants to know the area to the left of the value of interest. So it wants to know this 0.35 as its input. And then it wants the mean, and then the standard deviation. So there we go. So let's pull that up. We're going to do second vars on the calculator. Inverse norm is command number 3, and we put in 0.35, comma, 183.3, comma, and 50. And when I do that out, the value we get is 164.03. They want one decimal place, so it rounds to 0.0. So we'll fill that in our picture and say this number here is 164.0, and it's always a good logic check to make sure it came out smaller than your mean. If the area we were looking for to the left was less than 50%, then that value should be smaller than the mean, 164. Alright, so there is the answer for part A. Now let's scroll down a bit and take a look at part B. So part B, what is the mean which is the mean separating the bottom 35% of means from the top 65% of means? So notice really the only thing that has changed here is that one key word. Instead of talking about single values, we're now talking about sample means. Talking about 35% of means and 65% of means. So our distribution has changed. It's no longer the same as the population distribution. Now we'll need to divide our standard deviation by the sample size, because the size of that sample affects how likely it is for the mean of the sample to be far from the population mean. The bigger the sample is, the less likely the mean of that sample is to be far from the population mean. So let's draw a sketch here for this situation. While we can still see that information, let me write out. So now we're talking about a normal distribution, still with mean 183.3, but our standard deviation is going to be 50 divided by the square root of our sample size, which was 237. Alright, and now if we draw a picture for this situation, it's going to be the same normal curve, same shaped normal curve, with our mean at 183.3. Our value of interest still has 35% of observations below it. right? We're looking for the 35th percentile. So we know that's 0.35. So to find question mark here, we can still use the inverse norm command. We input the area to the left, which is 0.35. The mean, 183.3. The standard deviation is going to be 50. The division symbol to get that slash bar in your TI calculator. The square root symbol and 237, and then close those parentheses. So notice our standard deviation has decreased by quite a bit. So when we do that second vars to get inverse norm, 0.35, 183.3, and 50 divided by the square root of 237. And the number we're getting there is 182.048. We only went around to one decimal place, so that would be 0.0. So we could fill in this number here is 182.0. So notice, it's still below the mean, as we expect it should be. It's much closer to the mean, because in general, when we have a large sample, all sample averages are going to tend to be closer to the population mean. So our value here, 182.0. All right, and that's the end.